I got a phone call out of the blue, I think from Reagan. They had pond water, wanted to make it potable so they could be drinking it and using it. And apparently they'd called some other companies also, and through the process, I won. And I think it's real important that you really get there's a lot of information out there. People will give you a lot of information, and it's very confusing. And what I like to do is try to make it as simple as possible. Not all of you are water treatment experts, and so it's Fresh KC Water is the name of the company. Our website is kcwater.com. And so anyhow, I had no idea. They just asked me to talk about water treatment, and I had no idea what I was getting into until I got here this morning. So I'm very impressed, and I think what you're doing is very important, and you should all plan whether you have emergency water, whether you're pulling from a municipal water supply, doing your own thing, whatever it may be. Educate yourself, and that's what this is all about. I put this up here, and I pulled down that drop box. You'll notice on our webpage at kcwater.com, there's a whole area on water education. And because I've made my website more of an informational website to help the consumer kind of understand what's going on out there. This just happens to be the water IQ test that I put on there, 10 questions. It's a lot of fun, it's very interesting. Rod covered the first one there. About how much of our body is water. It's 60 to 70%, and water is pretty important for our health and our life, and so there's a lot of good information. I encourage you to educate yourself, or at least educate yourself enough to ask the smart questions and kind of understand what's going on. If we could go to the next slide, that'd be great. We're running out of water. The topic here is the water reuse and recycling. What would you do if you went to the kitchen faucet, turned it on, and no water came out? It could be a reality one day, and due to droughts across the country, our ground table waters are dropping. There are record lows in the reservoirs, and water's just not as plentiful as it used to be. So the reality of our water supply is imminent, and as our population grows, we're using more of it. Next. I think we all learned this back in school somewhere either in the 4th grade to the 9th grade. I think depending on your school system, we talked about the hydrological cycle. I keep it real simple. The water that the dinosaurs was drinking is the same water that we're drinking today. There is no new water on Earth. And then I always ask, does that mean we're drinking dinosaur wee-wee? I don't know. You can think about that a little bit. But there is no more new water, and that's why they're talking about a lot of the rivers are drying up by the time they get to the end, because everybody's using the water. And so through next cycle, or next slide there, our water is being so-called contaminated by many different sources. Even though the good Lord starts it out clean, it has to fall down through the sky, and it's picking up the carbon dioxide, the smoke, the sulfur. Water is what they call a universal solvent. And you can take clean water, if it doesn't have anything in it, it becomes one of the best cleaners that you can use, because things absorb into clean water so readily. That's why they call it the universal solvent. But that's why as it drops through the sky, it's cleaning the air, because it's all pulling all those pollutants out of the sky, whether it be the smoke or the acid rain. Then it hits the ground, and it dissolves all the things that are in the ground, go into the water, and picks up the odors, the pollutants, the herbicides, the pesticides, whatever it may be. It may look clear, it may look clean, but there's a lot of things that we can't see in water that are actually there. that you have to kind of pay attention to. Next slide, please. So what of our collection options do we have? You know, you have a lot of properties that have lakes and ponds on them. Over the last 15 years, I've kind of specialized in a lot of the lakes and the ponds and how to take that water and make it potable and usable. And it's a great source. If you know kind of what you're doing and you know a little bit about your lake and your pond, you can, they hold a lot of water. And in this area, even in high drought areas, a lot of them have a little bit of spring-fed water into them. It's not necessarily just runoff water, and they stay full, and you always have a constant supply of water. Drilled wells, it's this right over here. A lot of people think you can just poke a hole in the ground and get water. If you get with a good well driller here in the area, they'll tell you it's kind of hard to find water in this area just by poking a hole in the ground. And then the quality is susceptible. So again, as we go through here, we'll encourage talking to some of the experts. You know, before you go and spend, I think I was talking to Rod, you know, it's $6,000, $10,000, and you can get a dry hole, or you can get something that you can't use. It's a lot of money, and you might want to explore your options and different things. Rod, is that your well there? A lot of people, I don't know if you knew what a hand-dug well is, but it's a hole in the ground that's dug by hand. And it's usually lined with brick. We have a lot of customers that have bought the old farmsteads and that are out there, and this is the water supply. They're anywhere from 20 to 35. I've seen them as deep as 50 foot. And they're just down below the water table. The water just kind of seeps in and it comes up. And that's what they call a hand-dug well. And then the buzzword today is rainwater harvesting. There's more and more people today that want to get completely off the grid, as they say. And they are actually, and it's a source that, man, our grandparents used years ago. And if you notice, if you had a grandma or a grandpa, in my particular case, who used rainwater, they used it for washing and bathing, simply because it hadn't soaked through the ground and picked up all those minerals and everything. The rainwater is softer, which makes it more usable. That universal solvent comes in, it's better water to clean in. So it's something that's coming back, and it's really something to look at. I'm excited about that particular part of it simply because there's technology today that can clean it up, and pretty simply too. So it's very nice. Next slide, please. So let's talk a little bit about where your source of your water is coming from, the quantity of it, the quality, and the testing. The quality and the testing, I always encourage any type of water source that you have, whether it be from a well, even rainwater, whatever, have it sent to an independent EPA certified lab and have it tested for drinking water suitability. The reason I say an independent certified lab is because all water treatment dealers such as myself, any of them will come out and test your water, but you now have to be your own water treatment professional. It's your plant, it's your water, you need to have control over it, and I've just seen a lot of variances depending on what somebody maybe wanted to sell you on the quality of water that you may have had. So if you send it off to a lab, you can do it for $75 or less, and you have that independent test, and then you can sit down intelligently, talk about your water, and fix the things that need to be fixed, and maybe not fix the things that don't need to be fixed. You'll also want to test it annually for bacteria. A lot of people on wells, ponds, and lakes, they think, I've tested it once. But water does change. We'll talk a little bit about that. So you want to test it minimum annually. You can get that. A lot of your county extension agents will do it now for you. They even, I was at the WQA, Water Quality Association convention in San Antonio over the weekend, and now they have self-test kits that you can actually do it at your house, and you'll know. As I said, your own water treatment utility, so you, instead of relying on Johnson County Water District number 1, who our municipalities do a great job in testing the water several times throughout the day to make sure that we're not getting typhoid and hepatitis and those type of things. You now have to take control of your own water supply and make sure that you're doing those things. Local water experts, well drillers are important people to talk to. Don't just talk to one well driller. Talk to several well drillers. You'll be surprised the different answers that you'll get. And before you have a well drilled, check on that well driller. I follow up behind a lot of them, and I can sit here and say some of them are better than others. They're great. Some of them also deal with ponds, lakes. They'll go out and set the pump out in the pond. They'll pipe it up. There's sizing issues that you need to pay attention to. Got to get the right pump. They'll bring it up into a pressure tank, and so some of them are very familiar with that. I'm a certified water specialist, level 6 on the water treatment side. I'm a good source to talk to as far as who I would recommend to do different things throughout the house. I know when Terry got involved with me, and not knowing what he was doing, they needed somebody who could bring the water up from the pond, and I recommended somebody for them, and I think Scott's probably done a good job. I've followed behind him several times. So talk to different people, even as far as neighbors that are in the area. I mean, they can tell you a lot about the water, especially if they've got a wells and different things like that. Quantity. The EPA now has a website, and it's in the information sources here, but it's Surf Your Watershed. You can go and on the website, you can see where all the water flows in your area, where it's coming from. So you can determine maybe different things that are draining into your water supply. If you are going to do rainwater, you'll probably want to know the average annual precipitation that you get in an area. Rainwater harvesting is important even in the desert. So they don't get much rain, but it's important they collect all of it when they get there. If you're a well owner, there's some great information at wellowner.org that gives you some information about your water wells. Again, I talk about talking to the neighbors. They'll tell you whether ponds or lakes will dry up during high drought times. Even the wells, that they have different challenges. And again, research out your local water experts to talk to them. Next slide, please. So what are some of the storage challenges? With lakes and ponds, you got to worry about weed control, your runoff. Everybody knows that a lake and a pond turns over twice a year. That means the bottom of the lake comes up to the top, the water churns like this, and when that happens, there's usually an algae bloom, there's usually muddy, murky water, and you gotta prepare for those instances, because it's 2 to 3 weeks in the spring and the fall that if you're not prepared for it can make your water kind of miserable. Will it dry up in drought conditions? Your drilled and hand dug wells, is it high or low production? So, but when I talk about high or low production, you need so many gallons per minute in an average household to, to shower, to bathe, to flush a toilet, different things like that. And if your well production cannot keep up with that, you're going to run out of water sometime, and you don't have any water source. So if you have a low production well, there are ways of storing that water, even in the basement, and having that water always available, and it's constantly, you know, filling it up so that you have the proper amount of water to use out throughout the day. To start your search for potential problems, begin close to home. And this probably, this number 3 through 9 apply to whether it's a lake, a pond, a hand or drilled well, or rainwater. You know, do a survey around your well. Is there livestock nearby? Are pesticides being used on nearby agriculture crops or nurseries? Do you use lawn fertilizers throughout the well? Is your well downstream from your own or your neighborhood's septic system? You'd be surprised how many septic systems are leaching into wells. Is your well located near a road that is frequently salted or sprayed with de-icers during winter months? Aren't you glad your municipality takes care of all this for you? That's a little joke. Do you and your neighbors dispose of your household waste or use motor oil in the backyard, even in small amounts? If any of these items apply, it may be best to have your water tested, talk to a local public health department, certified water specialist, or agricultural extension agent to find a way to change some of those practices. Rainwater. You know, any roofing material can be used if you're going to use it for non-drinking. I think Rod said you used your rainwater for a lot of outside uses, water in the garden, different things like that. But if you're going to use rainwater for potable use, the best roof materials is metal, clay, cement. Although all roof material types have been used, you want to stay away from the asbestos. And they're usually in the older homes, and usually you know if you have that or not. Asphalt shingles can contribute to some grit in the system, so a pre-filter of some sort before it enters the cistern. I always recommend anyhow, because not only you have grit, but in this area you got leaves, you got sticks, you got all kinds of stuff that get up on our roofs, wherever you're collecting the water, so you want to just snap that out. They're real easy to do. There's different gutters that come down and have little screens on them that just reject all that stuff, and you're pretty much catching most of the water. Storage systems. A lot of people are using cisterns. In this area, they have to be underground because it freezes in the wintertime. And anything that's outside is going to freeze, it's going to crack. You're going to have some challenges unless you spend a lot of money heating it. So most of the ones I've seen are cisterns. I haven't seen anybody use it yet, but I understand now they have some bladders that can go underneath crawl spaces and different things like that that would work for collecting those type of things. So that's some of the challenges you have with storage. Next slide, please. Treatment types. Remember, no one filter removes everything from the water. Unfortunately, there's not a catch-all type thing out there, and that's why it's important to have the water test. That's why it's important to know what's in your water. It's important to know what you're concerned with, what you want to get out of it, because then you can put the different types of filters in the order that they should go in, and know by the time your water gets to the end that it's doing what you want it to do. So it ranges from media filters, cartridge filters, bag filters, absorption. People go, what's absorption? Carbon is that particular type of product. Things, when water goes over carbon, it absorbs your organics that are in the water, and organics are the chlorine, the herbicides, the pesticides. But the reason you will see on all carbon filters, and more and more people are getting the refrigerators with the filters in there, and they think, oh, I can change that once every 2 years, or they put those lights on there for a reason, because carbon is like a sponge. Once it absorbs so much, it will not absorb anymore, and it starts dumping. So you start putting more in the water than you actually think that you're taking out. So change the filters when your manufacturer tells you to change them. Chemical processes, that's the chlorines, iodines. Non-chemical processes, UV light doesn't use as a chemical, different things like that. Hollow fiber technology, I'm going to go into a little bit more. It's the newest technology out there, and what I really like about it is that you don't need electricity to make it work, there's no waste, and it's guaranteed to remove the bacteria, viruses, and cysts that are out there. So, and it's for whole house use. You can get 4 to 9 gallons per minute flow out of it. So now that you can shower, you can bathe, you can drink, you can use your water, flush your toilet, just like you normally would, but you know it's protected before it goes up there. And they've covered the gravity filters. Those are the pour in the top ones. Next one, please. Here's some treatment systems that we've done here locally. The first one on the top left up here, this gentleman had a low recovery well. So he had his well into a 12,000 gallon cistern, all right? It was naturally soft water, but he had bacteria. Now, was the bacteria coming from the well? Was it coming from the cistern? It's kind of hard to tell because, you know, you pump water into a cistern and you got that much water sitting anywhere, over time it's going to grow. So we took the test from, I always try to take the test directly from the well. We were getting some bacteria, but the bacteria count was higher coming from the cistern than it was from the well. So anyhow, he has, you see the 2 units. This gentleman built a big house. He has the big spa bathtubs that when you turn on the spigot, you need about 15 gallons per minute to to fill up your bathtub and stuff like that. So we just had to put 2 of them in series so that he had plenty of flow rate. But he's got a sediment filter that's sitting in here, actually he's got 2 of them, and then he's got reverse osmosis as a final backup for his drinking and cooking water. He was these here for the bacteria and virus removal, but he was also concerned with some herbicides, pesticides, different things, some of the heavy metals that some of these don't get out. This particular system, people had a drilled well, had hard water, had iron, had manganese and bacteria in the water. This particular unit's been, before when you had iron and manganese, we had to use chlorination, had to use an iron filter, had to use a water softener. Technology today is now with this, the media that they put on the inside of this, it removes the iron, the manganese, the hardness all in one swipe. It's very convenient. There's no mess for the homeowner to use. And then we followed it up with UV light to kill bacteria and viruses. And I shouldn't say kill. UV light does not kill bacteria and viruses. When bacteria or a virus gets into your stomach, it multiplies and it grows. And as it grows, that's what makes you sick. So what UV light does, it basically sterilizes that so it doesn't grow in your stomach. But the reason that they talk about you got to have clean water going across UV is because, let's say a hardness mineral is bigger than a bacteria and virus, and as it goes across, if it shades that bacteria and virus and the UV light doesn't touch it, you don't sterilize that. You basically ingest it and you don't have the protection. So you got to be cautious about using some of these technologies and make sure that you're doing it. Now, when I say that, there are some UV lights out now that have come out that you can run across some, it's called crossfire technology. And again, it's what's exciting about our business. They're starting to, develop products and stuff that you can run dirtier water across the UV light now and kill those type of things. This well here was drilled 600 feet. I was telling Rod, in this area, you drill below 100 feet, you're going to get into salt water, you're going to get into hydrogen sulfide. Everybody know what hydrogen sulfide, you ever smelled rotten eggs? Yeah, it's no fun, and it's not good for you either. So this system was put in for, basically they had over 4,000 parts per million total dissolved solids. The EPA recommends that you want to keep it under 500. They had hydrogen sulfide that was off the chart. I mean, this house stank when you walk into it. So anyhow, I don't know whether I might walk away from one of those jobs again. It was a good learning experience. We fixed it, but it takes a lot of maintenance to do that. So, but you know, the other choice was spending $30,000 to run a line from where the water was to the house, and so you know, there's a trade-off there that the homeowner had to make. This is our last pond job we just did out in Hillsdale Lake. We finished it up here about 2 weeks ago. He's got a submersible pump that's floated out in the middle of the pond, about 2 to 4 feet underneath the surface of the pond. It's pumped up to the pressure tank here. That's that blue tank that you see. And from there, we've got it's called Micro Z. It's a media that's self-backwashing that removes the algae, the dirt. It gets down to, they were talking about micron size, gets down to 5 microns. He had some hardness and a little bit of manganese in the water, so we got a water softener to remove that. And then it's going through this hollow fiber technology again, and we'll show you a little bit more about for bacteria and virus removal. And then on pond water, you get some taste and odor issues. You know, I don't know if you've ever gone down and smelled the lake or smelled the pond. We run it through carbon as the final process to help polish, take out those taste and odors. So, and then he's got it as a final process. He's got reverse osmosis there hanging on the wall. Next one, please. This is the hollow fiber technology that I was telling you about. That it's made by GE. It was a company out of Canada who developed it. Xenon, and they were using it in the municipal water supplies for municipalities to filter the water because of the technology. And when they first introduced it here in the United States, Maytag had the rights to it, so you may have seen it underneath the Maytag water purifier. Here about 1.5 years ago, GE bought out Xenon. And of course, they cut Maytag out of the will, and now it's called the GE Home Springs. Next one, please. What's really nice about the unit is flow only occurs when the water is used. You only need 30 pounds of pressure to push the water through it. It's what they call dead-end filtration, which means that you know, it stops it right here, and the water goes through, and the contaminants stay right where that's at. The only thing that you're going to need, and if you go, you know, if your power goes off, most of you are probably going to have, if you're setting up something, you're going to have the generator that's still running the water pump, and you know, you're still going to have your water pressure there. And Rod was talking about reverse osmosis, how the waste is there, and there's no waste with this. It's you put a gallon in it, you get a gallon out of it, and it's really nice. The next slide here, I think it talks a little bit about it, and I've got a unit outside there, but if you can imagine a straw, and that straw has tiny little pores in it, and they were talking about micron size. This is 0.02 microns. So that's why it's rated and been tested to remove those bacteria, viruses, and cysts. The water goes down the outside, and that 30 pounds of pressure or plus pushes the water molecule through that hole, and the bacteria and viruses just can't pass through. The hole's not big enough. So they put, I don't know how many, they got 1,000 of those little straws in there, and so that's how they can get the water flow rates up to your 4 to 7 to 9 gallons per minute. It's 10 years ago, I couldn't, that's how new this technology is, and I couldn't sit up here. There was, before we had to use chlorination systems, and you need electricity for that to make the pumps work and things like that. You need backwashing filters and either UV lights. So this technology, and we'll see, Dr. Williams probably saw some of these units in these disaster areas because they've sent a lot of them out because of the technology and what they'll do. Next one, please. Here was Katrina, the hurricane off the Gulf Coast. We all know the flood and everything like that. But they took 40 of these home spring systems to the area. They were installed in community centers, hotels, schools, and churches, and it gave potable drinking water for everybody there. Next one, please. Down in Florida, they have the hurricanes, and this was a unit that was put into a home down there. They have backup power supplies. They wanted reliable water treatment. They had the extended boil water alerts for weeks after hurricane. Have you noticed we've had more boil water alerts in the last 5-6 years? You know why? The EPA started mandating that our water treatment companies had to inform us about those type of alerts, and that started about 7-8 years ago. Before, all I had to do was put a notification in the newspaper, said we had a boil water alert. Now they have to publicly tell you. You will also notice that once a year they're sending you out a water quality. That was also required. And what that tells you on there, it may say that everything is safe, and they do a great job with what they have to deal with, but they have to tell you everything that they found in the water, even if it's below safety levels. So when you see a list of things on there that's in your water, and they're just telling you at what levels it's there. So these people already had particular part of equipment, but when you go into a boil water thing, it means there's bacteria and viruses that could possibly be in the water. So they added the Home Springs system on the other side of it as the final to capture that. Next one, please. This is open pond drinking water. Again, this was a little bit different because they used this pond when the well ran dry, so it sat there, and when they say turbidity levels, 100 NTUs, that's pretty dirty water, folks. You can't see through it. And so anyhow, again, the solution was there was a sand filter put in, followed by the hollow fiber filtration, and it was producing 10 gallons per minute drinking water from the source. And they used it for the local homes as well as surrounding communities. Next one, please. Rainwater collection. This was a private residence collecting organic matter, and I don't know, anybody have cistern? Do you have to get down in there and clean it every once in a while? Pretty nasty, isn't it? Yeah, and I would imagine, Rod, bottom of your tanks and so forth over time, they get pretty dirty. And so, you can get in there and clean it and disinfect it and different things like that, or have something that helps protect so you don't have to do it as often. So anyhow, oops, excuse me. This was a rainwater collection and reuse system that they used the system on. Next one, please. This was a winery, and they were hauling in water, and so they tapped a pond that was there, and so now they don't have to haul in all that water. They're using it directly from the pond. Next one, please. This was a case study at a large private residence on municipal water supply, and they just wanted healthier water. They didn't trust the municipality and wanted to make sure that they had something on that just in case something happened, they knew that they had good, clean drinking water coming into their house and all the faucets. Next one, please. I put this one up because just to let you know how good the technology is, it does meet the US EPA guidelines to provide miscible water. This happened to be a small town that had problems with their water. They put in a bank of these, and now they meet all the guidelines for having clean water for the whole town. So that's where the technology really started from, and what's really nice is they've made it available for homeowners at a decent price. Next one, please. So you got cabins, you got cottages, you got vacation homes. I've sold a lot of the Berkeley, those gravity filters for people up in Canada. It's a great way of filtering your water. You know, if you want something so that you can bathe and shower and act like a normal person, this is a great way to go too. Next one, please. And if you want to get completely off the grid, there's a company out of Colorado that is taking that system, putting solar panels on the top, and you got your pump in there, you got your battery, you got everything, and it makes water. You just stick the thing wherever you want to pull your water from, and you don't even need electricity and different things like that. That's it's getting pretty exciting. This company here is they know what they're doing, and it's nice to be associated with people who take the technology of today and even take it farther. Next one, please. They're putting this same technology. I don't know the straws that Dr. Williams had, if that's the same technology that's in there, but they're putting it in straws. That's what this is here on the left. You've got small, just kind of inline filters now that have that technology in it, that are rated to remove the bacteria, viruses, so you don't have to go big. In the medical field is now seeing them in shower heads, because when you have wounds and you have different things, you cannot afford to have any type of bacteria and viruses getting in that, so they're putting them on shower heads. So as they're using, even though it's municipal water, they're making sure that water is bacteria and virus free. So it's, again, pretty exciting what's going on. Next one, please. And there's your gravity filters. Probably one of the most simplest ways to get clean water, and especially in an emergency. I had no idea when I put those slides up there that you guys are going to be kind of talking about that, but that's a great way to go. Next slide, please. So what do you need to do? Really just know a little bit. Don't believe everything you read on the web. Even though I referred you to my website, don't believe everything I say. Know a little bit about what's going on. You know your source, where your water is coming from, know your storage, how you're going to store it, know your quality of water, the quantity that you're going to have available, know your water system. You know, all equipment requires some type of maintenance of some sort, whether you're changing filters, what do you have to do with it? Even the home spring system, every year there's a integrity test that's done on the equipment to make sure that there's one of those holes hasn't ripped open or something like that, and you can actually test the equipment to make sure that it is doing what it's supposed to be doing. And know your water treatment providers. I think it's a big, I see so many people that talk to one person and they do something, and then they realize, well, it isn't quite what I was looking for, and then they start doing their research, and then they start, asking questions, and they get a little disappointed and maybe jumping into something that they should have known a little bit more about. Next one, please. I believe they put this in the book, just some sources for information on wells. There's several different websites that will help educate yourself a little bit. The ponds, there's your Surf Your Watershed, rainwater, several different areas. There's books out here that I saw that have, all kinds of information for you, probably even better than a lot of these things here. Treatment areas of treatment, general water info, different things like that. Next one, please. That's it. Any questions? Somebody was asking about air. Was that you? Yeah. You got a dehumidifier you ever had a dehumidifier in your basement or anything? Same. Yeah, same principle. They're taking water out of the air, but these units that you're seeing now, then they got a filtration system on the inside, and they're taking that water and running it through like a gravity type filter and just basically cleaning it. So yeah, it's a technology. Actually, it's been out there for years. It's the only challenge I have is the amount of electricity it takes to make that happen. So, distilled water is your highest form of water, your cleanest water that you can get. But when you start analyzing cost per gallon, because you got to use a lot of electricity, you got to boil that water. It's, depending on the distiller, anywhere from 35 to 50 cents to make a gallon of water. So that's why a lot of people are using reverse osmosis today, because your cost per gallon is just in filter changes, and you're getting around the 6 to 8 cents a gallon range as far as cost per gallon. If you had solar, yeah. So, yes. Uh-huh. Yes. Are they? Yeah. I know, well, radioactivity naturally occurs in the ground, and water softening will help remove some of that. Reverse osmosis gets into some of that too. Again, it's like anything, what kind of levels are you getting? And once you know the amount of levels, it's like reverse osmosis will remove. Okay. Reverse osmosis will remove fluoride from water, but if you have really high levels of fluoride, it's only,
With distillation, remove radioactive materials?
It's a good question. I would have to ask on that. A good distill is radioactive. Is that organic or inorganic? Can be both. Yeah. Yeah. Because a good distiller will have carbon filtration incorporated with it, because there are some organics that will not boil off, and you have to capture them with carbon. So it's a good question. Yes. Depending on the size, $3,800 to $4,200 installed. So, it's actually about well, I'll tell you exactly here. It's a 9 gallon per minute flow, and I would recommend a little bit the bigger one. So. 10 years is what they say. Now, you got to be kind of cautious. If you put it on municipal water, I'm sure there's not going to be any challenge getting it. GE is pretty conservative with their numbers usually. So, but if you're running really, and it works good for turbid water, which is, we get a lot of ponds that get a lot of runoff, and they get really cloudy and so forth, and it does a really good job of removing that, but you need to just it does backwash. There's about a 5-minute backwash on it, and it uses anywhere from 7 to 12 gallons of water when it does that, so it will flush that out. So if it's set up properly, it'll last 10 years, is what they say. So that's what they tell me, that's what I say. I ask them, what do you do after 10 years? They say there'll probably be better technology out by then. Yes?
A couple quick things on that GE technology. You showed some inline and some other products.
Mm-hmm.
GE products, or is there resellers that are reselling that?
They're resellers that are reselling it, yes.
And secondly, on UV, do you know what the exposure time?
All UV lights are rated for a certain gallon per minute flow rate, and you always want to put a flow control so you never exceed. So whatever UV light, it could be 2 gallons per minute up to 12 gallons per minute, and you want to put a flow restrictor that will control that amount of flow so that it maintains consistency. Yes, sir.
Your presentation said that it took 30 pounds of pressure
Uh-huh.
to activate that fiber deal, but then you showed a gravity feed. Is that the same technology?
No, the gravity feed is ceramic, and those are those ones that they have out here, the Berkshire. And gravity means you just dump the water in the top, and it just soaks down through. What do they make, up to 20 gallons a day? Something like that, I think the top one. 6 to 8 gallons an hour now? Okay. So.
Does that purify as well as the hollow fiber?
No. Those are a 0.5 micron rating, which they'll get into the bacteria, but the viruses they don't say that they'll do.
Would chlorine take care of the viruses? Is that one of those filters?
No, it does not. I've used a lot of chlorination systems over the years, but I always took the chlorine out before I drank it or anything like that. So chlorine is a great disinfectant, but it's not good to be bathing and showering in it and drinking it. I'll just leave it at that. You can do your own little research on it and stuff like that. So anytime I've used chlorination, I've always taken that chlorine out. Right. Right. No. And actually the Berkey filters have combination ceramic and carbon, so it will remove the chlorine from the, I caution you, use chlorine, but pay attention to what you're doing. Just because a little works doesn't mean a lot is a lot better. You can get it too high and it will hurt you. So it's like dumping too much bleach into the washing machine. What does it do to your clothes? You can